So that example didn't actually have a minimum average cost. Let's try one that does. Suppose C of Q is, what do I want to put it at? 500 plus 0.2 Q squared. So this Q squared means now our costs per item aren't staying flat, they're accelerating. So more items are going to get more and more expensive over time. So there probably is some middle ground where the thing is minimized. One, let's minimize average cost. And then two, I want to ask the question, what's marginal cost at that production level? At what production level? The one that minimizes average cost. So, how do we do this? Step one, write down the average cost function. How do I write it down? It's total cost divided by quantity. So that's 500 plus 0.2 Q squared divided by Q. Calculus is easier if we split this into separate fractions. That's 500 over Q plus 0.2 Q squared over Q. That reduces. I'm going to write this as a power. That's 500 Q to the negative 1 plus 0.2 just Q. What's my domain? I guess my domain is Q bigger than 0. Let's minimize it. Let's take the derivative. The derivative of that is negative 500 Q to the negative 2. I guess I didn't say it this time, but I would have said show it's a minimum. Especially since the last example didn't have a minimum. There's weird things that can happen in this version of the problem, so we're actually going to do the test to do something to figure out how do I know it's a minimum. Usually the second derivative is the best way to do that. Negative 1 falls down, 500 Q to the new exponent is negative 2, plus that's Q to the 1, I get just 0.2. I'm going to set that equal to 0 in a second. Before I do that, can I take the second derivative real easily? That negative falls down, makes it a positive 1000 Q to the negative 3 plus nothing is 1000 over Q cubed. That's positive. Actually, Q cubed could be negative, but only when Q is negative. We only care about when Q is positive. We're not trying to sell negative objects. So on the region we care about, it's positive. So A double prime is positive, says that we're always concave up, says if there's a critical point, it must be a global max. Or a global max on the interval from 0 to infinity, which is the region we want it to be a global max on. So we're good. When does this thing equal 0? That's negative 500 over Q squared plus 0.2. When do you equal 0? Let's move that to the other side and get 0.2 equals 500 over Q squared. Let's multiply both sides by Q squared. So 0.2 Q squared is 500. Let's divide both sides by 0.2. That's 5,000 over 2. 5,000 over 2 is 2,500. So Q is plus or minus the square root of 2,500. We don't care about the negative one because we only care about positive Q values. We get that Q is 50. Q equals 50 is the quantity that minimizes average costs. I wouldn't say that this answer has minimized average costs. I would probably want to say what the value is. The problem was vague, just saying minimize isn't clarifying what the answer is, but I feel like the correct answer in this circumstance is say the y value that is the minimum. Here the a value of 50 is, where was our formula? It was the original divided by q, so 500 plus 0.2 q squared divided by Q. I don't need the split up fraction version because I'm not taking derivatives right now. This is the easier way to plug in numbers. 500 plus 0.2 times 50 squared is 2500, divided by 50. 1/5 of 2500 is 500. 500 plus 500 over 50, that's 1000 over 50. That's 100 over 5, that's 20. So, producing 50 items gives the minimum average cost of $20 per item. The lowest our average cost can ever get is $20 per item, and we get that best possible deal when we produce 50 items. What's question 2? Question 2 is what's marginal cost at that production level? We never took marginal cost. Where's our cost function? It's 500 plus 0.2 q squared. Oh, don't crash on me. Our cost function is 500 plus 0.2 q squared. We want what's marginal cost at that production level of 50. I need to find the marginal cost function. That means derivative. Marginal cost function is 0.4 q. So marginal cost at a production level of 50 is 0.4 times 50. That's 4 times 5, that's 20. Marginal cost at Q equals 50 is $20 per item. Well, hey, that's the same answer we had just a second ago from what the minimum average cost is. The minimum average cost equals the marginal cost at that point. This is a place to learn something. Hey, let's learn this thing. We're in the context of another Goldilocks, where we can learn about comparing. We can learn whether average cost is increasing or decreasing by comparing average cost to marginal cost.